Okay, the first part of your notes is what you guys just copied down. So I know some of you are still copying down, most of you are moving on to cutting and pasting. So while you are cutting and gluing those into your flip books, I want to go ahead and talk about the things that you just copied down. So we'll start getting into our notes here. So the first part of this table is everything that you just copied down. So these are the theorems for this section, okay? Difference between a theorem and a postulate. So remember, postulates we talked about that we assume that they're true, but we can't prove that they're true mathematically. We can't find a counterexample in every single scenario we come up with. It's true, but we can't mathematically prove it's true. Theorems, we can actually prove that they are true. So if you want to kind of rank them, theorems would be a little bit better than a postulate just because you are able to prove that they are true. So we have 5 theorems in this section. Okay, the first one is called the vertical angles theorem, which we are going to actually prove down here below. Now, the vertical angles theorem is something that we kind of had, we kind of thought this was true, but we haven't been able to prove that it's true up until now. So, vertical angle theorem says that vertical angles are congruent. Now, remember, vertical angles, okay, are the angles that are across from each other. So, like the picture down here at the bottom of your notes, it would be like 1 and 3. Would be vertical angles, and then 2 and 4 are vertical angles. The vertical angle theorem, which, like I said, we're going to prove down here below, proves that vertical angles are congruent, and that's going to be very handy to be able to use. Okay, theorem 2.2 and theorem 2.3 are super similar. They are the congruent supplements theorem and the congruent complements theorem. So this just basically says, okay, you've got 3 angles, okay? So you've got your first angle, okay, and then, so like, let's say we've got this angle, there's another angle that is its supplement, which means these 2 angles add to be 180, okay, and then you take away this angle, and you bring in another angle, and this angle is also supplementary to the angle we already had. They are also supplementary. If 2 angles are supplements to the same angle, those 2 angles are going to be congruent. We're going to prove that today as well, and it also works with complement. So if 2 angles are complementary to this same angle, then they are congruent. Theorem 2.4 is pretty obvious. All right angles are congruent. All right angles are 90 degrees, so they all measure the same, so of course they're congruent. That one would be a pretty easy one to prove. And then theorem 2.5, if 2 angles are congruent, measure the same, and supplementary. So I have 2 angles that measure the same, that add to give you a straight line, they have to be right angles. Okay, they have to be, okay? Now, one question I had yesterday that I was going to address, and I don't know when I was going to address it, but this would be a great time to address it. Remember that your reasons, whenever we're doing our proofs, your reasons are going to be postulates, theorems, definitions, or properties. So everything we're putting in your flip book are things that you can use as a reason when you are doing your proof. So yesterday I had a student ask me, well, instead of writing angle addition postulate, can I write postulate 1-4? And I'm like, awesome question. No. Because here's the thing. Postulate 1.4 isn't universal through the whole world. I wish it was, but it's not. Postulate 1, it's the angle addition postulate is postulate 1.4 in our textbook. But if you go to a school next door, maybe they use a different math textbook, and maybe it's postulate 2.7 or something totally different. The number, okay, does not define what the theorem or the postulate is. So you can't use postulate 1.4 or theorem 2.3. You have to use the name of the theorem or the name of the postulate. Okay, does that make sense? Okay. So let's go down here, and what we're going to do to kind of get used to kind of practice doing a theorem again, and then kind of in general, once we prove something, so what we're going to prove here is we are going to prove that angles 1 and 3 are congruent, which are vertical angles. So we're going to prove that vertical angles will always be congruent. And once you prove that it's true, you're allowed to use it. So we're going to kind of come up with these things that it seems like it's true, that we're like, well, I think it's true, but if we haven't proved that it's true, you can't use it, okay? But as soon as we prove it's true, as soon as we put it in your flip book, then we're able to use it as a reason for your proofs, okay? So for this theorem, for this proof, okay, remember we have our statements and our reasons. We are given that angle 1 and angle 3 are vertical angles, okay? We want to prove that angle 1 is congruent to angle 3. Okay, so first thing, my first statement is going to be angle 1 and angle 3 are vertical angles because it's the given. Yeah, because it's the given. That's always going to be your first statement. Okay. Now, what we want to do next, okay, looking at my picture, we're going to kind of pick out some information that I also know. Just my picture. So I know 1 and 3 are congruent. Looking at my picture, I know that angles 1 and 2 are supplementary. How would I know that? How do I know angles 1 and 2 are supplementary? They're a linear pair, would be the technical definition there. So my second statement is going to be angle 1 and angle 2 are supplementary. And we know that because angles that form a linear pair are supplementary. Okay, I know that. Angles 1 and 2 are supplementary. And I know that because they, like Elijah said, they form a straight line. Angles that are a linear pair are supplementary. Now, in that same statement, I'm going to use that same reason to identify another pair. So, angle 1 and 2 are supplementary, and so are angles 2 and 3. So let's do that as well. Just in the same statement here, so still in statement 2, let's say angles 2 and angles 3 are supplementary. I don't need another reason. It's the same reason. It's under the same statement. It would be for the same reason, so we can combine those together. Okay, now, kind of going forward here. Since I know angles 1 and 2 are supplementary, what does that mean? I don't know that. Just because they're supplementary, angles 1 and 2 are supplementary, they equal 180. So let's make that our third statement. The measure of angle 1 plus the measure of angle 2 equals 180. And I could do the same thing with angles 2 and 3. So the measure of angle 2 plus the measure of angle 3, those also equal 180. And my reason, remember your reasons have to be postulates, theorems, definitions, or properties. This would be like a definition. This is the definition of supplementary angles, right? That's the whole purpose of supplementary angles, that they add to give you 180. Okay, we're almost there. Okay, now, this is one of the properties that we wanted to use yesterday, but we couldn't, okay? If the measure of angle 1 plus measure of angle 2 equal 180, and the measure of angle 2 plus the measure of angle 3 equal 180, I have these two things that both equal 180. Here's the thing, guys. If I have two things, if these two things equal the same thing, they have to equal each other, right? If they both equal 180, they would have to equal each other. So that's going to be my next statement. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Now, like I said, this is one of the properties we wanted to use yesterday. What property tells me that if two things, and it's not really worded this way, but if two things equal the same thing, they're equal to each other? Okay. This was the transitive property. Now the transitive property, and this is going to be the transitive property of congruence. Sorry, no, it's not congruent. Just kidding, it's not a congruence because it's an equal sign. It's just a transitive property. Okay. Now the transitive property in your flip book says if A equals B and B equals C, then A equals C. You just reword it a little bit, and it would say if A equals B and C equals B, A and C equal the same thing. You just flip one of those around. They equal each other. So anytime you can read it either way. Okay. Now here's the thing. Look at what I have here. Angle 1 plus angle 2 equals angle 2 plus angle 3. Keep in mind what I'm trying to do. Sometimes it helps to get the angle inside. I'm trying to get angle 1 equal to angle 3. Well, on the left I have angle 1 and on the right I have angle 3. So that's a start, right? But I also on both sides have the measure of angle 2. What can I do? Yeah. So my next statement is going to be the measure of angle 1 equals the measure of angle 3. I'm just going to get rid of the measure of angle 2. How did I get rid of the measure of angle 2 on both sides? The subtraction property of equality. Now remember, the whole goal is, this is almost my answer, right? My answer, my final step needs to say angle 1 is congruent to angle 3. Well, but if the measure of angle 1 equals the measure of angle 3, I mean, the next rational step would be, well, the angle 1 has to be congruent to angle 3 because congruent angles have the same measure, right? That's like the whole point of congruent angles. So congruent angles have the same measure. And just like that, we have proved that vertical angles are congruent. There we go. So now we are allowed to use that. Now, if in one of my proofs, if I need to use vertical angles that are congruent, I can now use that because of this theorem. Okay? Questions on this proof? Okay, let's get this glued in. So this should be glued into page 29. Page 29. Now, while you guys are getting this glued in and getting your table of contents filled out, this is the last section in chapter 2. Okay? All right, so first thing, we want to find the value of each variable, then find the measure of each angle. When you guys get to your homework, it's going to do this in kind of 2 separate steps. The first problem will say, find the value of each variable, and the next 2 problems say, oh, and then find the angles. So we're just going to do it all in one. So, number 1, let's draw a picture of intersecting lines. Got our picture of intersecting lines. And then, let's say this angle here is 2x plus 21 degrees. The only reason it's in parentheses is because it's a quantity, just to kind of show that it's the whole thing degrees, not like 2x plus 21 degrees, right? It's just saying that it's the whole thing degrees. And then we have 4x degrees. Okay, so I want to find the value of each variable. So I have these 2 angles. How would you classify these angles? What kind of angles are they? They're vertical angles. And what do I know about vertical angles? They're congruent. Their measures are equal. So I know that 2x plus 21 equals 4x. They are congruent. Their measures are equal. So first thing is I need to find the value of each variable. So we need to solve for x. So subtract 2x from both sides. So we would have 21 equals 2x. Divide by 2 and we should get x equals 10.5. Okay, which is one of your answers. Then I want you to find the measure of each angle. Now there are 4 angles, but we know that since they're vertical angles, these angles measure the same and these angles measure the same. So to find the measure of these angles, I know what x is, so I'm just going to plug x in. Because they measure the same, so you don't plug it in both places. Which one do you want to plug it in for? Probably the 4x. So 4 times 10.5  10.5 would be 42 degrees. There's one of your answers. 42 degrees. There's one of your answers. 42 times 10.5 would be 42 degrees. 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 42 times 10.5 would be 42 degre Now, if I know that this is 42, I know these two angles are the same. So how am I going to find the measure of one of those angles? These two are linear pairs, which means they add to give me 180. So I could take 180 minus 42, which would give me 138 degrees. Okay, let's do another one of those. Okay, number 2, so another pair of intersecting lines. Okay, this time this angle is 4x. This top angle is y. And then this angle is 24. Okay, so I have two variables to find this time. I have an x and a y. So let's start with x. How could I find the value of x? These are vertical angles, which means they are congruent. So 4x equals 24. Divide by 4, we should get x equals 6. There's one of my variables. Now, if x equals 6, how can I find y? Right, this is a linear pair, right? So to find out what y is, we're going to take 180 minus 24, and we would get 156, which is going to be your value for y. So you found your x, you found your y. Now, if I want to find the value of each angle, what are the big angles here? What do the big angles measure? What do these big angles measure? Somebody whispered it, I heard it. 156, right? Because that's what y equals. What does the other two angles measure? 24, right? Big value. Yeah, very good. Okay, questions on using the vertical angle theorem. Okay. All right, now the only other thing we're going to do is we're going to do two proofs. Okay, so the first one, we're going to do a 2-column proof. So let's start with this. We are given angle 1 is congruent to angle 4. I want to prove that angle 2 is congruent to angle 3. And then we're going to have a picture. So we have these intersecting lines, and then we'll number the angles going clockwise, 1, 2, 3, 4. Now, although it really looks like these are perpendicular lines, do I know that they're perpendicular lines? No. And remember, no matter how much they look like a right angle, if they don't tell you it's a right angle, you cannot assume they are a right angle. Okay? You cannot assume that. Now, I do know that angle 1 is congruent to angle 4, so if you want to mark that on your diagram, you can. But that's all that I know. Okay? So let's start our proof here. Remember, on your proof, we need a column for our statements, and then a column for our reasons. Okay, and our first statement will be angle 1 is congruent to angle 4. Why? It's the given. It's the given. Now, you're not going to have to do a proof start to finish, but to kind of start thinking about them whenever you will have to do them start to finish, what we're looking for is maybe any other information that I think might be useful that I know. So from this diagram, what else can I conclude from this diagram that I know for a fact, I know for certain?
Angle 1 isn't congruent to angle 4.
Okay, angle 1 and angle 3 are congruent. You're right on that. And actually, just because the order of the, okay, no, we'll do that. Okay, sorry. I went in a wrong order last hour and it kind of messed things up. We're going to do that. Hey, angle 1 is congruent to angle 3. I know that for a fact. Why? Okay, we'll say the vertical angle theorem. Yeah, vertical angle theorem. I know that. We just talked about that. Now, if you can, kind of taking you guys through the thought process, if you can then go back and tie those two steps together in any way, we want to do that. So if angle 1 is congruent to angle 4, and angle 1 is congruent to angle 3, what could I say? Okay, before we do that, we are going to have to do that, but before we do that, I want to see if I can tie these together. What do you think? Angle 4 is congruent to angle 3, because look, angle 1 is congruent to angle 4, and angle 1 is congruent to angle 3. Angle 4 and 3 are both congruent to the same thing. You see that? So they have to be congruent to each other. Angle 4 has to be congruent to angle 3. If they're congruent to the same thing, they have to be congruent to each other. What tells me that? That's the transitive property of congruence, because we're talking about angles here. Okay? Once again, kind of keep in mind where we're trying to get to. We're trying to get to angle 2 and angle 3. Okay, so I've got the angle 3 mixed in here. Now we need to kind of get the angle 2 mixed in here. And Leo, you were on the right track. What can we say to get angle 2 going here? Okay, I know that angle 4 is congruent to angle 2 because the vertical angles theorem. And then we're going to kind of repeat a step here. Well, if angle 4 is congruent to angle 3, and angle 4 is congruent to angle 2, exactly, angle 2 has to be congruent to angle 3 because the transitive property of congruence. Very good. Okay. So kind of use the same two properties there. Okay. Questions on that one? Okay. All right, so I mentioned whenever we introduce proofs that we have the 2-column proofs, and then we also have what's called a paragraph proof. Now, second hour was not a fan of paragraph proofs, neither am I, but I'm going to introduce them to you guys, and you won't have to, not today anyway, write a paragraph proof, but you'll kind of like read one and kind of fill in the blanks, kind of like you did yesterday with the 2-column proof. Okay? So here's what we're going to want to do. We are going to be given angles 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary. So angles 1 and 3 are supplementary, and angles 2 and 3 are supplementary. We want to prove that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. It might help to have a picture. They gave me a picture whenever I copied this down. So let's have this kind of big obtuse angle as angle 3. And then we'll have angle 1 and angle 2. So to kind of make sense of everything that we're given, it says angle 1 and 3 are supplementary. So if I combine those, give me 180, right? And angle 3 and angle 2 are supplementary as well. I'm trying to prove that these two angles have to be congruent, okay, which is the angle supplements theorem, okay? Now, even though this is a paragraph proof, you're still going to start with the same thing. You're still going to start with your given statement. But instead of writing it as a simple statement and then your reason, you're going to combine that into one sentence. So what I'm going to say is I'm going to say angle 1 and angle 3 are supplementary because of the given. Okay? I know that angles 1 and 3 are supplementary because that information was given to me. Okay, now, if angles 1 and 3 are supplementary, what does that mean? What in the world is supplementary? Okay, they add to be 180. So let's do that next. Well, that means, the measure of angle 1 plus the measure of angle 3 equals 180. And you always have to give your reason afterwards. Well, the reason, because the definition of supplementary angles. Okay, then we're basically going to do the exact same thing, but with that second given statement. Because, I mean, it's the same thing, right? If 2 and 3 are supplementary, it means you can add those together. So, we'll do the same thing. So, angle 2 and angle 3 are supplementary because of the given. So, the measure of angle 2 plus the measure of angle 3 equals 180. Because, once again, because the definition of supplementary angles. Just kind of the same thing twice, okay? That says basically the same thing, but with 2 different sets of angles. Does that make sense? So far, do you guys like the paragraph proofs? They're awful, aren't they? I know, they're so hard to keep track of everything. But then what you kind of have to, just like we would do with our 2-column proof, you kind of have to sort through what you have and see, okay, well, where can I go from now? So what I see is okay, the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180. Anytime you see something that looks like this is going to be something you're going to do a lot with proofs. So you have these 2 things that equal the same thing. What can I do with those 2 things then? I can set them equal to each other. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. How do I know that? It's not substitution. I guess technically it's going to be substitution. It's going to be the transitive property is what we use. Because of the transitive property. Okay, now, once again, kind of thinking of where we're trying to go. I'm trying to get angle 1 is congruent to angle 2. Where I'm at right now is the measure of angle 1 plus 3 equals 2 plus 3. I need 1 equal to 2. But this happened before, right? On both sides, I have the measure of angle 3. How can I get rid of the measure of angle 3? Yeah, I can subtract the measure of angle 3 from both sides. So we'll just kind of put that in words there by subtracting the measure of angle 3 from both sides by the subtraction property of equality, by subtracting the measure of angle 3 from both sides by the subtraction property of equality, the measure of angle 1 equals the measure of angle 2. And then we can, if the measure of angle 1 equals the measure of angle 2, well, that means angle 1 has to be congruent to angle 2 because congruent angles have the same measure.